What an absolute miserable day here in Houston, Texas. Just been raining all freaking day. But that's not gonna take the smile off this welder's face. Our good friends over at Denaliweld sent us this big old freaking crate, man. It's gonna be the newest addition to my shop, and I can't tell you how freaking excited I am to get this thing out and try it out. You ready to open this thing up? What's in the box? I know I am. This is screw to open. Dang, those are freaking long. I think there's some more on this side. See if I can get this sucker off. I need help. Lucky for me, I brought my buddy Chris Taki here. He's a professional when it comes to welding and race car driving. I don't know about race cars.
Not really professional, but you know, I enjoy myself, that's for sure.
I brought you not only to help me lift this box off, but to also do some TIG welding. You're a lot slicker with the smaller stuff than I am, and I want a good comparison. This machine compared to some TIG welding. Let's get it up.
Sounds good.
That's good. Leave it right there. All boxed up. What is that?
Very nice.
I don't know if you think that's gonna fit me. Let's check out this right here. This is what we came for. Oh, look at that right there.
Ready?
Oops. Alright, let's get this thing cleaned up and lay out everything we got here on the table.
Okay.
Well, Chris is kind of a head scratcher. There's a lot of stuff in here. I'm a little underqualified. I've seen lasers before, we played with them. I've never actually had to set one up. I always had an engineer fella who was there. So this is gonna be a learning experience for us both.
We got this.
Do know that this is similar to a ground. We got some cables here. We got some focus lenses. We've got some different laser welding nozzles for different joint designs. All the boxes, all the packaging, everything was like really well put together. It comes with a little remote. So I think this is for your welding hood. That's interesting. A couple other pins and plugs and stuff. This wire feed cable, of course our wire feeder right here. We got different rollers, a whole bunch of different stuff. We got a spool of wire in there. I'm gonna have to make a phone call to these dudes and be like, hey, I got it plugged in, now what? So I made my phone call, Chris. And Viola, the Denaliweld Jet 2000. Made the phone call, they made me feel safe, a little bit stupid because everything's labeled. So just to walk you through this machine as it sits right now, it also comes with that cover, which is nice because the fans seem to be located here on the top of the machine. So if it was just chilling around, I'd want that cover on it for the majority of the time. Of course, got our gas bottles here. We got nitrogen and argon, depending on what we weld today. And it came with a regulator and a hose. Now this hose, didn't know, had a quick connect to this hose because it's like a little reducer bob so that we can get the gas in there. The next thing we'll worry about getting into the back of it is this continuity clip, right? This is essentially your welder's ground. It's not a ground because we're not running DC positive or negative on any of this stuff. It just needs this on our work part somewhere,
yes,
so that it knows there's metal there. When it comes to the actual laser cleaning, you don't need that continuity switch. And then the other back of this thing is, of course, the gun. Do not touch anything on this gun. This is the fiber laser. The fiber optics are all running in here. There's nothing on the back of that you need to touch. This is like the liner for it. This is what it comes with too, and the wire feeder. The wire feeder is incredibly light. Can you move that gun for me? Yeah. It goes on there really easy, but it has this goofy freaking, like, look how long that is.
Yeah, it's pretty long.
And it's supposed to go to the back of this. And then you have your liner here that's super short. Yeah. Way shorter than the gun, which makes sense. The liner has to be a little bit shorter if you're gonna be running aluminum wire. You can't really have a big long one, but the fact that it has a long lead there means I can move this light wire feeder wherever I need so that I can, you know, compensate for that.
Yeah, the cord does the same thing.
The cord does the same thing. It's gonna go straight into this wire feeder, and it's pretty easy to install. You'll just do the quick connect in the back, and then in the front here, all you do is just plug it in, and then there's this little set screw with a Phillips head. But I was told to make sure you don't push it too far in that it hits the drive roller. Okay. Right? We wanna just pull it back just a little bit before we set our set screw. We're running 045 wire for our stainless, aluminum, and carbon steel, so we've got those rollers. It comes with an absolute metric ton of rollers.
It's a standard size spool as like any type of wire feed machine, right?
I think it'll hold a big one. Right now we've got some 10-pound spools.
Okay.
So that's what we're gonna run today. And it comes with all these little wrenches and stuff so that you can connect your liners to your welding gun. Or again, if you just don't wanna run this right now. Autogenous welds on stainless, you know, you don't need this whole charcoal wire feeder on top of it. You can just switch your tips. It came with a whole bunch of these tips for different types of welding on different types of joint configurations, along with these 2 sets of Allen keys so that you can change out your welding tips for your welding joints, or maybe you want to do any type of weld cleaning. You can swap it out here. We're going to get everything set up. Right now it's for cleaning mode. Let's jump into that now. All right guys, so I've gotten a lot of comments. I've used this machine now for about a week. Done a lot of cleaning, posted some shorts about it, and one of those comments that we got was, can you remove a tattoo with it? I know what you can do as far as on metal. Chris, you got a tattoo on your leg. Laser safety is no joke, but hop up right here for me. Let's get that tattoo. Spin around, spin around. Put this box on your head for safety. All right, you ready? I think I got it off. You might want to look at this though. Is that too much?
Dude, I don't think that's right.
Laser safety's no joke. Let's power this bad boy on. It's gonna run off single phase or 3-phase power. It's not a 110 machine, as you can imagine. One thing here is you see you're automatically locked out of your screen. All you gotta do is come up to the top right and unlock it. And then a laser switch to be on. You have to hit that to turn the laser on. Same thing with the wire feeder. You have an on and off for your wire feeder. It took me a long time to realize I have to hit that button. I literally called customer support. I was like, it's not working. They're like, did you hit the on button? And then of course has your emergency switch off. And then of course the key for the actual laser. So even the laser switch that says it's on, it's not on until you put the key in the actual laser and turn it to on. Right now we're gonna start with the laser cleaning. If you wanna go through any of the modes here, you click on the logo at the top, and you'll have to go through each one of these. All the instructions are built in here. Right now we're not gonna worry about how to switch it out. We're just gonna switch it to the cleaning mode. Hit OK. We're in cleaning. This is how you set your wattage. We got 2,000 watts as max right here. We're at 1,500. I think that's where we'll start. We got our laser frequency, our wobble frequency, and you can also change your width from 50 to 80 is the max. And again, to get this thing to work, you got to turn on and you got to turn it on. Right now we should have action to that laser. In all serious guys, these lasers are no joke. In this cleaning mode, you can point it at the concrete, you can point it at metal, you can point it at wood. Because this doesn't need the continuity switch, you can shoot it at just about anything. So you've got to be very careful about your surroundings, right? Lasers shooting infrared light, your welding hood, it's not going to help you.
No.
You got to have this infrared stuff. I don't have a spare one for you, so as we do some welding and stuff today, one of us is going to have to not be in the room. So luckily I got cameras on tripods, we can still capture everything. The laser cleaning is super nice on this machine. At 1,500 watts, I got to use it in a couple different places. I've tried it all around my shop, just on random stuff. Okay. Rust, it just chews through, no problemo. Awesome. And of course it'll get through grease. I tried it on my griddle. Rust, grease, it'll get through it. You kind of have to work it a little bit back and forth, but it works. If you have a tube, right, and you start going linear with it, instead of trying to make like sweeps like this, but go linear with the tube so the length of the laser is going, it works a lot better. Yeah. Now I really put this thing to the test when I put it on the back of my welding trailer, hooked it up to the Ranger, because I knew it was gonna work in my shop power, but I wanted to see how it handled on a generator. Okay. I took it out to a field, to a local place called P6 Farms here in Montgomery, Texas. It's a really cool place. They got a lot of events and everything. My father-in-law paints for them a lot, and he has painted this railing 1,000 times over. The rails were old drill stem pipes, so it rusted through and bubbled up. So he asked me to come out there and clean up all those spots so that he can repaint it better. And this thing did just the trick, right? Especially on those rusty bits, it does the best. However, 3, 4, 5 layers of this paint, it had a hard time. It took some time.
I can imagine.
Not only that, but it's sitting next to that Ranger in the Texas sun. We hit duty cycle on it often. It was really convenient for what it was worth. There wasn't nobody out there but the cows, so it was safe enough for us to use it. You can get it with the wire wheel and stuff and kind of do the same thing. However, in those spots where like you couldn't get a grinder, that's where the thing was.
Yeah, this is gonna surpass all of that.
This was where it was invaluable. When it comes to carbon steel, great. Stainless steel, you're not gonna see a lot. If there's no oxidation and there's no stuff on it, it's not gonna really do a whole lot to the material. You're still gonna need to have to wipe this thing down, clean it up, maybe even take a light abrasive to it. Now we're gonna get into the nitty-gritty of the welding lesson today, and the whole reason why I brought you is you're a slick TIG welder. I'm gonna have you, who's never welded with the laser before, weld with the laser, weld with TIG. We're gonna do a cross-sectional cut and etch, carbon, stainless, aluminum. Moving into the settings for each of these materials, it's very simple. We gotta make sure we have the right gas. For carbon and stainless, they're gonna recommend nitrogen. For aluminum, they're gonna recommend argon. It's the only time that we're gonna switch that out. From cleaning mode, we're gonna run a higher CFH, closer to 40. For welding mode, we might turn it down to like 30. Right now we're in cleaning mode, and you can see the diagram here. This is what will really help you understand how to take off either the cleaning head and put back on the welding head or vice versa. Now when you're ready to switch from one to the other, you just go to the welding function and it'll give you some nuances and give you some advice as far as where you need to line up your wire feeder and all that good jazz. Once you hit function switch, it'll get you right into that weld mode. Now, as far as what material you're going to be working with, you come up into the settings, right? So you'll see that it has material and then stainless steel, and then if we start going down from stainless steel, you'll see the aluminum and carbon steel. This is a 2000 watt laser, so its max penetration is going to be closer to 1/4 inch, but it's not going to get quite there, right? So for 4mm carbon steel, the program is 15. So we'll hit process 15, and then we'll go ahead and hit OK and import. So now go ahead and input all of our settings as far as our laser power, the wobble width, laser frequency, wobble frequency. Of course, we have to switch our laser on, and we need to switch our wire feeder on. Obviously, the wire feeder needs to be turned on up at the top. I haven't really got into the wire feeder as much. You can obviously select your menu here as far as a delay, feed rate, which is what we're going to be mainly staying on, the retract speed, because you can push the wire out and push it back in. You can retract it, but I usually just snip the wire in right where it's at. The main thing is our inches per minute. I didn't know where to set this. No one gave me any advice. I think everyone can weld in like a flat position with a laser. That's what we're gonna do today. It's super simple as long as you just follow the fundamentals of pointing the laser in the right direction as far as your work angle. And then your travel angle, you just need to make sure that your handle, your hand is parallel with your work the entire time. You'll never want to point the laser directly into the work. I welded flat with this, and then I welded a little project on the side. I had like a little bracket and a little piece of pipe, just something that I could find around the shop to try to weld not flat. And when these laser companies tell you that anyone can weld flat. I put it on my roller and started trying to work around, trying to get different spots. Half of it was garbage because I didn't know the wire feeder wasn't on. So half of it was just trash. But the other half of it, the welds were good, but just moving around, those nuances were not easy to get a consistent weld. Move back into flat, no matter if we put in the 5356 wire, the stainless wire, the carbon wire, switching and navigating through the screen and all the layout seemed to be pretty easy. It was just the same process we just went through. The nuance is you have to kind of find the wire feed that you want. They say 1 inch of wire is 1 inch of weld. And you can see it only goes up to 4. If we had it up to 4, that sucker moves, dude. Yeah. That thing flies. For what we're gonna be working on, I have seen some success, at least from the outside, not looking at the cross section. Somewhere around this is gonna work for me. We're gonna try to operate on all 3 of these materials today. We've got all of our carbon, our stainless, our aluminum. It's all chopped up. You prepped it for us. We've got it all ready to go, but we're gonna keep whatever the presets are on the machine. And you can adjust your wobble frequency if you have like a bigger gap or a different type of joint. I have not dived into the nuances of this yet. If you guys wanna see more of me playing with a welding machine like this to see what not to do with it. What happens when you set this all the way up or all the way down? That's something I haven't played with. So we're gonna stick to the presets today. I'm gonna let you rip a couple, see if you can get them all down. We'll do carbon first.
Okay, sounds good. It's got me over here holding post flow. Pretty good.
I'm never doing that before. What do you think?
That run's pretty cool, to be honest with you.
Yeah. And remind you, this is thicker material than what it's really rated for right now, or about max, but that's just so we have enough material to cut and etch. Not necessarily that that's what we would be welding on, but it looks pretty good. Now we're gonna go ahead and pull back that wire and then replace it with stainless steel. We don't have to do anything with our gas. All we're gonna do now is change the wire and the weld setting to stainless steel.
All right.
Notice I had him put on some sleeves. Infrared light can still give you a little bit of a sunburn. That's also a reason why to wear a full face protection hood. Even the laser safe glasses these days will be perfectly safe for you. Stuff can happen, man. Yeah, it's a safety deal, so keep your sleeves on.
You're never too cool for safety.
Yeah, it looks like we're getting some depth in there, so I'm pretty confident.
Oh yeah,
see, oh yeah,
definitely penetrated.
Yeah. All right, aluminum next. Let me switch it over, and we'll have to switch over to argon this time instead of the nitrogen.
Okay.
Now, would you rather weld like that on aluminum or with a spool gun or TIG torch?
TIG torch, dude. It's a lot different.
But that's the first time you ever did it.
Yeah, first time ever, yeah.
That's comparatively speaking to your first time
I mean, it's
TIGging
definitely fast. You're not welding gaps with anything like this, I don't believe.
Yeah, we're gonna probably try some gap welding.
Yeah?
Not today, but I'm definitely gonna put the limits on the gaps.
I've been close to these machines before. I've never used one, but I've heard talks of you being able to gap maybe like a 1/4 inch. I'd rather just, you know, give me some fat 1/8 and just...
All right, rip it. One more, and then we're gonna switch to that TIG that you like so much.
It's definitely interesting, I will give it that. From a production standpoint, I totally see it.
Yeah, same machine though. All you did was switch wire. The only big difference, and I'll have to say it, so anyone that's listening, this is easy, but I tried to put it on little tubing where you have to change your angle. It's just like any other welding process. As soon as you go from different positions and different pipes and all that, things get harder.
Yeah, it would definitely take a shop a lot less time to weld with this than it would be freehand TIG.
Speaking of, let's switch.
Okay.
So dainty, little tackies.
How much gas you got on right now?
A lot.
I can
You
tell.
want more?
No, less, like 30. Actually, you can do like 20.
Yeah, I like hurricanes coming out of my
I can
torch.
tell.
Remember, you're going for penetration. Got about 80 amps on it.
Well, it's not real great, but we're all right. It should penetrate anyway.
You want me to turn it up any?
If you shut that door, that'd be great.
That was the other thing I noticed when, you know, at least with the laser, less affected, I think, by, you know, a little bit of nuances and breezes. I will say, it's taking a lot longer
Definitely.
for you to weld that than the laser. It's kind of obvious. We'll really see when it comes to that penetration. I'm expecting similar results, like TIG and laser having similar results.
Yeah.
But speed's definitely going to be the biggest factor, I think. There's a wasp in here trying to find its way to make a house. It's about to meet 2,000 watts of cleaning mode if it's not too careful. Stainless is over, let's switch to carbon. Waiting on a welder.
Alright, per usual, huh?
Now Chris is running off the Typhoon 230, the old stallion over here on the rack. We've got our settings going on for stainless and carbon steel. We've got our foot pedal, high frequency, the normal setup. We're using 16th inch diameter wire on this thicker material to hopefully get a little bit more penetration, whereas you might want to wire up on something like that to get kind of more of the fillet weld we're looking for.
So don't at me for the undercut.
Flip it and weld it. Something's dirty, huh?
Yeah, somebody didn't clean off the front of that plate.
Oh, that was me. Those look slick, buddy. I'm sorry, laser. You can't beat the satisfaction in that right there.
No, you can't.
You can't. You just, that's just.
Let me run the back of this.
I turned it to 200. You get them all welded?
Yeah.
Oh, perfect. Get out. I don't need you no more.
Cool.
Get.
We'll see you next time, man.
Yeah, don't call again about that per diem. You know how he lost his leg? Trying to feed a bunch of baby alligator gars in Bass Pro Shop. Didn't work out, did it?
Did not. Thanks, buddy.
Later. But for real though, thanks Chris for coming over to the shop and welding with me today. He had to run because he's a busy dude. Performance racing stuff, obviously fabrication, he's got a lot of parts to run back and do. He left all the sanding and etching for me. In the past, we haven't been doing right by you guys by having the right type of equipment to do cut and etch samples. So I reached out to ES Laboratories and we were able to get some stuff sent to me because of my CWI having that as a certification, and we were able to get the right kind of stuff for our carbon steel, our stainless steel, and our aluminum. So what we're gonna have to do is we're gonna cut into these samples and we're gonna actually do what I don't normally do and get really fine to the actual, the grit that we use. Normally I'll take an angle grinder to it. This time we're really gonna get down in the weeds when it comes to sanding things down, even down into hand sanding these samples to 1,000 grit, especially for the carbon steel in order to see what we need to see. Let's get to work. We've got all 6 of our coupons here, the carbon steel, the stainless steel, and the aluminum TIG coupons, and the carbon stainless and the aluminum laser coupons. We're going to take it over to the bandsaw to get the cross section of each one of these coupons. Now the bandsaw didn't really like cutting through the stainless, so I had to take the stainless over to an angle grinder. That way we can get through it without putting up too much of a fight. Once we got all of our cross sections cut, I went ahead and took it to a roll-lock disc with different sanding and abrasives from 3M. Got some Cubitron 3 sanding wheels and some of these gray discs here. They're really good for surface conditioning and putting a nice finish on it. But we're going to start with something aggressive like an 80 grit and then move to a 120 grit, hitting each one of these carbon, stainless steel, and the aluminum coupons. And then I'm going to switch over to the gray disc, and that's going to put a nice finish on all of these. Now we can't stop there. I was advised by the folks over at ES Laboratories that we really need to put a nice finish on these. So we're going to go ahead and wet sand everything. Starting with the 600 grit, we're going to put our carbon steel down and start just working it. Same thing with our stainless steel and our aluminum. That aluminum will send shivers up your spine. It just gets hung up so easy. Once we get through the 600 grit, then we're going to move on to 800 grit and switching the direction of our movement. So now I'm holding that coupon at a different angle so that we can see the previous scratches get removed from the previous grit. That's kind of the goal here with each one of these. Once we're done with that 800, now it's to 1000 grit. Again, with the same process, switching from this way to that way and trying to get those other scratches out. Really is a tedious process, but it has to be done properly in order to get good results. Always switching a different sanding pad for each one of these materials as to not cross-contaminate them, because that could give us some issues when it comes to looking at it. The etching process can be tedious as well. You really just want to make sure it starts off nice and clean, right? I started the carbon steel one off, and honestly, even after cleaning it, applying the etch, having proper PPE on there, I wasn't able to see a whole lot. So I kind of changed my motive up a little bit, started with the alcohol and cleaned everything up, and then took a torch to it. I wanted to make sure that there was no alcohol in the little crack of this lap joint, because I think that was giving me some issues on the carbon steel. So once the stainless steel was done and etched, you could really start to see that weld nugget in the weld metal. TIG and laser had very close to the same weld size. It's just cool to see the different results that you get. I would probably say that the laser definitely penetrated deeper into that metal for sure. The aluminum had pretty much the same results and was also an easier etch to do. Once applying that torch, I think that torch really helped out a lot to get the results. The aluminum had a lot bigger weld size when it comes to the actual TIG welding compared to the laser, but similar penetration results. So looking for more penetration and maybe less reinforcement, if that's the goal, laser might be the option for you. I wanted redemption on the carbon steel, so I went back to the 1000 to try to get it cleaned up again and then put a torch to it. Again, I don't know if it was my fault or not. You can see that this sanding is not an even job. You live and you learn. From what I can tell, we probably get some similar results on the carbon steel coupon as we got on the other two. Oh, I still for the life of me can't get anything to really show up on here. I mean, I get a little faint glimpse of something on the carbon really similar to what we saw on the stainless steel. I would have to reckon it's probably a lot of my sanding job. Everything when it comes to micro etching really needs to be sanded really square, and I think I was just not keeping it perfect. Maybe the lap joint holding a little bit of water and maybe even some of the alcohol trapped in there seems to like pushing my etch a little bit out of the way. The biggest thing to take away is just the depth of penetration. The shape of the weld nugget now is you see just a big old rectangle running right into it, and I think that's pretty fascinating. Super stoked to have this here in the shop. If you have any more questions about the Denaliweld laser, check out the link down below. I'm sure those guys would be happy to help, as well as getting more laser welding content for you guys using this machine and just testing things out, just like we did with MIG, stick, all these things. Laser being one of those newer processes and being more readily available, we got to give it to you. We'll see you guys on the next weld. Stuff can happen, man. It's a safety deal, so keep your sleeves on, man.
Never too cool for safety.
Get off my face, dude. Nope. This guy. Grab this guy. You just still like it like that? You just like listening to that?
Give me the high frequency noise.